Now we've arrived at a point when we can start tackling the more juicy aspects of regular expressions. We're going to introduce the first meta characters that are relevant to our introduction to pattern matching. And a meta character is a character that stands for something other than what it looks like. So for instance, in our pelican pattern that we were searching for before, each of those characters within the pattern, the P, the E, the L, the I, the C, the A, and the N, all stand for exactly what they look like they stand for. So when we ask Perl to search for a P, we're searching for the letter P and nothing else, and the same for each of the other characters. However, with the meta characters we're going to look at, we're introducing an element of flexibility to our patterns that take them beyond a simple searching for a substring of the kind that we could do using the index function. The first one we're going to look at is the dot. Now in our string that we've just set up here, and we've set it to the default variable, we've got three words here that immediately jump out as having a similarity. Of course, the similarity between them is that they all rhyme and that they're all spelt in a very similar way. Fox, box, and ox. If we were to put into a way that a computer is able to understand the similarity between these three words, we'd have to say something like it ends in OX, but there could be something else before it. We're going to get more sophisticated in the way we have variable lengths to the patterns that we're looking at, but just to begin with, I'm going to introduce the first of our meta characters, and that is the dot. What we're doing here is we're filling the matches array once again, and we're looking at matching a pattern globally using the G modifier. But what are we actually looking for here? There are no instances of a full stop followed by O and X within our default variable. So this looks like a match that is going to fail. Actually, what we've got here is the first of our meta characters matching any character at all. Now this is a wildcard. You can think of it like the joker in a pack of cards. It stands for any of the other cards we want. So when we run our search for .ox, we're actually looking for any character followed by O and X. So the matches array now contains three elements. It contains fox because F matches any character, box, and ox. Now there's something a little possibly confusing about the last one. If you look over here at how I've spelled out each of the elements contained within the matches array, you'll notice that I've included a space before the final word there, the ox. Now that's not a typo. When Perl is searching for the pattern there, it matches a space character exactly the same way as it matches any other character. It doesn't look at space as simply a gap between other characters, it looks at it as a character in its own right. So what we've done is we've matched space OX in the same way as we've matched BOX and FOX. Let's take a quick look at our text editor, and we're just going to map out that exact same set of matches here, and we're going to use a for each loop once again to loop through each of the elements within the matches array, and we're going to follow each one with a new line. Now when we move over to our command prompt and run the script, it's kind of a little clearer as to what's happening within the array. The space is stored as part of the third element there. That is the first letter of that 3-character string which makes up the third element of the matches array. So our wildcard character allows us to extend simple searching for fixed substrings into a whole lot more flexible territory, and we're moving here now into a much more sophisticated way of matching patterns using regular expressions.